So in this video, we will learn how to use LabVIEW for loop. LabVIEW provides several types of loops. For example, there is a time loop, there is a while loop, and there is a for loop. In this video, we will focus on for loop. For loop is used when we already know the number of iterations that a loop need to make. If the number of iterations is not known at the commencement of loop operations, then the proper loop is while loop. So let's go and see the various features of for loop. Let's place a for loop. And so here are the two parts of the for loop. The n, which is the number of iterations. Vi is broken, meaning that we have to specify the number of iterations beforehand, or the Vi will not operate. And the I, which is the iteration which is read only. The first iteration is 0 based. So let's create an array and see how arrays behave with for loops. Let's place a constant. Let's create two elements. Let's say 3 and 6. So as soon as I connect this array with the for loop border, you see the broken Vi is now fixed. Why? Because the loop can find out how many elements are in the array, and the loop will now iterate that number of times. In our case, it is 2. This symbol with 2 square brackets shows that auto indexing is enabled, meaning that as the loop iterates, one element of the array will be used each time. Let's see how it works. Let's create an indicator. Let's see how many times this loop iterates by creating a let's turn on execution highlighting. So first time 3 is gone in, 6 is gone in, and if you go to the front panel, you can see that the loop has iterated 2 times. First time was 0 index and second time was 1 index. So each time we executed, first 3 entered, then the 6, and the loop stopped. So let's see what happens if we have arrays of different size. Suppose we have an array of 3 elements and an array of, let's say, 4 elements. So how many times the loop will iterate? And furthermore, let's say we add a constant here, say 12 elements. So how many times will the loop iterate? As you can see, that the loop has iterated the least number of times, meaning it refused 12, 3 and 4, and it used the least number of times that it could iterate. Another feature of this loop is that you can add, by right clicking, you can add a conditional terminal, meaning that it can act now like a while loop as well as a for loop. So you can create a condition here, and if that condition is fulfilled, meaning that stop button is pressed before it has done its two iterations, then the loop will stop. Let's go and see some other behaviors of our loop. Let's remove this one and this one and this constant. So if we pass the wire through and create an indicator, then the same elements will pass through as were coming in. If we go and see this array, we will see that the same number of elements are here, because the mode by default that is turned on is auto indexing. So let's see other modes. Let's change the mode, tunnel mode, and the last value. Let's see how it operates. You see the tunnel is now filled. Let's create an indicator and see how it operates. So now, as you will see, only the last element has gone out of the loop to the tunnel if last value is turned on. As it is the scalar value. Another mode is called, let's create a duplicate array. Let's give it a value of 1 and 2. If we output this array, what you will see is by default it will create a 2D array, as these two double lines are showing. We run the code and expand this array. You see it has 2 rows and 2 columns. This is the default behavior, but which is on if we keep the auto indexing on. But if we right click and tell it to use concatenating mode, then let's see what happens. Let's create an indicator, call it concatenating mode. Let's see how it behaves. So in this mode, what LabVIEW did was, instead of creating a 2D array, it appended the first array with the second array which was produced in the second iteration and kept the dimension same, that is 1D array. One last mode is called conditional. So as you see, the question mark has appeared and we have to specify a condition here. Let's say we want to specify a condition. This is used for filtering data out. Let's use greater, and let's say if this data is greater than, let's say, 4, only then pass it on, otherwise refuse it. So if we create an indicator, run the VI, only if the data passes and this condition is true, only then the data will output. Since the condition was greater than 3, 6 should appear in this array. And if we look through the array, we'll see that that is the case. The data has now been filtered.